So systems of linear inequalities, just like systems of linear equations, are basically two or more linear inequalities put together into a group. So our objective today is to graph and solve systems of linear inequalities with two variables. If you'll follow along with me here. Sorry. A system of linear inequalities is a set of two or more linear inequalities containing two or more variables. The solutions of a system of linear inequalities consist of all the ordered pairs that satisfy all the linear inequalities in the system. So in the first section, when we are trying to tell whether the ordered pair is a solution of the given system, we need to do exactly what we did yesterday, except now instead of plugging the numbers into just one of the inequalities, we're going to plug it into both. So what are we going to plug in for x? Riley?
-1.
And for y?
-3.
-3. So the first inequality would look like this. -3 is less than or equal to -3 times -1 plus 1. So now we just need to work that out and see if it's true. -3 times -1 is 4. I mean 4, sorry. I was getting a step ahead of myself. Is 3. 3 plus 1 is 4. So is 4 greater than or equal to -3?
That's true.
That is true. Okay. Let's try the second equation. In the second equation, again, we're going to plug in -3 is for y and -1 for x. So work out the operations on the right-hand side. 2 times -1 is -2. -2 plus 2 is 0. Is -3 less than 0?
Yes.
Yes. So since these are both
Yes.
true, is this a solution?
Yes.
Yes.
Yeah.
Exact same concept on the second example. What are we plugging in for x
0.
and for y?
1.
1.
Okay, so that would be 1 is less than -3 times 0 plus 2, or 1 is less than 2. Is that true?
Yes.
Okay, let's try the second one. 1 is greater than or equal to 0 minus 1, or 1 is greater than or equal to -1. True? Okay, so is it a solution? Yes. Uh-huh.
What if on one of them, will there ever be one that's like, one of them is like correct and then the other one's not?
Yes. And what would you do in that situation?
Would it be not?
Uh-huh. If one is true and one is false, it is not a solution. It has to be true of both inequalities in order for it to be a solution. Okay, the next paragraph says, to show all the solutions of a system, graph the solutions of each inequality. The solutions of the system are represented by the overlapping shaded regions. The instructions say, graph the system of linear inequalities, give two ordered pairs that are solutions and two that are not solutions. So what we are doing today is exactly what we did yesterday, except instead of only graphing one inequality at a time, we're going to graph two inequalities at a time. So we're going to take each one of these and graph them individually, and then we're going to look for the portion where their shaded regions overlap. So let's start with the first equation. Y is less than or equal to 3. Since both of these equations are in slope-intercept form, I can go ahead and start graphing. So I'm going to draw my coordinate plane. And we'll start with the first inequality. Y is less than or equal to 3. So the y-intercept of this inequality is 3. And the slope is what? Right. A slope of 0 is a horizontal line. So the line is going to go straight across just like this. I'm using a solid line because why? Because of that or equal to is why I'm using a solid line. Now I need to shade. You always want to shade before you start your next line. So grab one of your colored pencils and decide, are we going to shade above this line or below it?
Below.
Below, because it's less than. So you want to shade lightly all of the area under that line. Remember, you're about to have to graph another line, so don't shade so dark that you can't read the graph anymore. All right, now we're going to graph the second line. Y is greater than negative x plus 5. So, where am I going to start? What's the y-intercept of this problem? 5. Now, what's the slope? Negative 1. So what direction do I need to go in? Now you'll notice I'm making my line as long as I possibly can because it's going to make this solution a whole lot easier to read. Now, do I need to connect those points with a dotted line or a solid line? Dotted because it's greater than and not greater than or equal to. So here's my dotted line. With your other colored pencil, shade that line. Do I need to shade above it or below it? Above. Now remember, the solutions are only the overlapping region. So the solutions are in the area that are colored with both colors. So once you identify that, you can use one of your colors to kind of go over it a little bit darker so it's easier to see. It's right here, kind of makes a triangle. Now, the second part of the instructions say give two ordered pairs that are solutions and two ordered pairs that are not solutions. So over to the left here, we're going to write solutions and not solutions. So basically, we need two ordered pairs that are within the double shaded region and two ordered pairs that are outside of the double shaded region. Okay, so what's one ordered pair that would be inside that double shaded region? Somewhere in here. I don't know if that's quite in it yet. That would be 1, 2, 3, 4 right here.
And then you've got 6, no, you've got 8, -4.
Okay, 8, -4 would be down here. Okay, 10, -4 would be in it. What else could you do? You need to go over a little further on the x-axis. 8, -1 would work, yeah. There's obviously way more ordered pairs than that than you could use, but those are two of the ordered pairs that are solutions because they're inside that shaded region. Now, what are two ordered pairs that are not solutions? Good. In this case, choosing not solutions is a little bit easier because the non-shaded region is much bigger than the shaded region. Okay, questions so far? As you can see, I don't think this is any more difficult than what we did yesterday. There's just a whole lot of things to think about. So it's important that you're working very carefully because there's many things that go into getting this problem correct. Okay, let's look at the next example. It gives us the system -3x plus 2y is greater than or equal to 2, and y is less than 4x plus 3. So now in this problem, I do need to change the first equation to put it into slope-intercept form first. So, Mary Grace, how would I change that into slope-intercept form?
The first problem, you would add 3x to the other side and then divide the 2 by on both sides.
And then what was the second part?
Divide 2 on both sides, divide all of the
Mm-hmm. So now I have the equation y is greater than or equal to 3/2 x plus 1. So now I can go ahead and start graphing. Fortunately, this graph didn't show up too well on the copy, but we'll just do the best that we can here. So Grace, where am I going to start with y is greater than 3/2 x plus 1? Okay. And where am I going to go from there? Up 3 to the right 2. Good. You can also go down 3 to the left 2. Now, should I connect my points with a dotted line or a solid line? Solid, because it's greater than or equal to. And where should I shade? Above. Because it's greater than. Shade all this area over here. Remember, always shade your first line before you start working on the second line. It's a whole lot, it's more confusing to try to go back and shade them both. There's too much going on once you have both lines on there. Okay, so y is less than 4x plus 3.
Oh. Okay, so you have to have a slope intercept for the slope. You have to add 3x to the other side.
Okay, y, we're on this one right here. Y is less than 4x plus 3. Is that in slope-intercept form?
Yeah, that's what it is.
Okay. Where would I start with this one? Okay. And where would I go from there? Yep. Okay, and should I connect those points with a smooth line or a dotted line?
Watch you.
Oh.
Okay, and should I shade that above or below? Below, because it's less than. So I'm going to shade all this area below that line. So this time, the part where they overlap is relatively small. It's just between, just this top area right here. So once you see it, color it in a little bit darker so it's easier to recognize.
And I can give you
So again, we're going to find two ordered pairs that are solutions, and two ordered pairs that are not solutions. What's one?
you can have you can have 1,
Uh-huh.
3.
1, 3 would be a solution. What would be another one?
1, 4. Or 2, 4.
Yeah, we'll do 2, 4. Now choosing not solutions should be easy because there's almost the whole thing is not in the shaded region. What are two
8, 1,
ordered pairs that are not solutions? 1, 8, 1.
and -2, 4.
Pretty much any ordered pair in the second, third, or fourth quadrant would not be a solution. Okay, you guys ready to try one on your own?
Oh, yeah.
I want you to try very carefully only the first example on the back page. When you're finished, raise your hand and I'll check to make sure it's right.
Do we have to do this when you finish?
Yes. Finished.
You want to do the next one?
Wait on the next one. Sure. That's great. Thank you. Okay, we're running out of time, so I do want to go ahead and show you this last one as well. First of all, this is what that one should have looked like. It should have had this shaded region over on the left done. Now, on the bottom equation, we don't have time to work through it, but something you may have noticed by looking at this is that they both have the same slope, which means they are parallel lines. When you go to shade them, what do you notice about the shading in this last example? They don't overlap. The only time it's possible for them to not overlap is when you have parallel lines. If that happens, the answer is no solutions. Now, that won't always happen just because they're parallel. You can have parallel lines that do have solutions, but sometimes parallel lines will not overlap so that there'll be no solutions. Okay, I'm going to put your homework up on the screen so that you can write it down quickly and then you may go. So here's your homework, page 424, numbers 16 through 22. Let me come pick up those. Once you write that down, you guys can go ahead and go. Don't forget, we do have a quiz tomorrow, so if you find yourself struggling on tonight's homework, please let me know.
Please give me a quick call. Someone can give me something. I love it.
Alright, see you guys tomorrow.
Thank you, Ms. Hudson.
You're welcome. Have a good day.